Okay, so I'm going to go over Boyle's Law real quick. So, what does this law entail? So, Boyle's Law, remember, is indirectly proportional between the volume and the pressure. So, volume of a given gas is indirectly proportional to its pressure if the temperature is constant. Constant means the same if you don't know what it means. So, anyways, what this means is you can write V and P. So if the volume goes up, the pressure goes down. The volume goes down, pressure goes up. That's how this law works. I'm going to show you an example equation so you can see what I'm talking about. All right. So let me copy it from here because I'm not rewriting all these. Okay. So if you need to pause the video to copy this for a second, go ahead and do that. All right. If a gas at 25 degrees Celsius occupies 3.60 liters at 1 atmosphere of pressure, what will its volume be at a pressure of 2.5 atmospheres? So the way you solve this is you have P1V1 equals P2V2. So what's happening here is you're multiplying both of these together, getting a number. They should be equal in terms of the ratios. So let's fill this out. Reading the question, this doesn't matter. The temperature is irrelevant in this point because it's constant. So we have to label our volumes, which is in liters. So that's V1. We don't have a V2. And then we have P1, P2. So we're obviously doing simple algebra, solving for an equation. Solving for one variable. So let's fill this in. We have 1.00 ATM, because it's in atmospheres, times 3.60 liters equals 2.50 atmospheres times V2. You could write X, whatever, it doesn't matter. It's just you're solving for this spot right there. So to solve for it, you simply divide the 2.50 atmospheres out. And yes, units are important, so you need to write them. So now you have atmospheres over atmospheres. It cancels, and you're left with liters. So I'm going to pull up the calculator and do this real quick. 3.6 times 1 is 3.6, so I'm not going to do that part. But divided by 2.5, we can see that as the pressure has gone up, the volume has gone down. So V2 equals 1.44 liters. Now, say we wanted to use the same starting conditions, but maybe the volume or the pressure is less. So let's find out what happens. So we still have 1.00 atmospheres, 3.60 liters, but instead of 2.5 atmospheres, now we have, 0.372 atmospheres, and we don't know the volume. So again, you just divide out the pressure. And this works if you're finding for the volume too, and you have, if you're finding for the pressure and you have two volumes. Same thing. And then 0.372 atmospheres. So let's put this in the calculator. It's going to give us another volume. 3.6 divided by 0.372. And that would be about 9.68 liters. So as you can see, as the pressure went down, the volume went up. And that's pretty much it for Boyle's Law.